Look who's up here. It's Jonathan. He's got a subject that everybody's going to have questions about. It's Phobos 3, and it's reworking the range API for it.
Okie doke. Range API is heavily used in Phobos v2, and in general, this has worked out extremely well for us. And we want to build on that with Phobos v3. We don't want to go and completely change what we're doing. We want to build on what we've been doing and just make it better. But there are some issues that we've found over time that we haven't been able to fix with the current range API because making the changes would break people's code. Given that we are now doing a new set of modules with Phobos v3, we have an opportunity to change the API, so we are changing the API. But this is very much an iterative change. It is not a completely drastic rework where we're changing all the paradigms and whatnot. There are some people who want that, but that's not what we're electing to do. So hopefully by the end of this, with Phobos v3, the ranges will be quite similar to what you have in Phobos v2, just with some improvements. Just a quick overview in terms of what ranges are. They're essentially D's answer to C++ iterators, whereas C++ iterators point at a single element and are effectively an abstraction for pointers. D's ranges point at a list or sequence of elements and are treated more like an abstraction for dynamic arrays or slices. And you have multiple categories of ranges similar to C++ iterators, and the most featureful version would be random access ranges, and those are just pretty much outright an abstraction for dynamic arrays and have pretty much all the same functionality as a dynamic array, except that they have none of the appending or allocation stuff going on. It just has the capability to look at the index into the range to see all the various elements and shrink it to iterate through it, just like you can do with a dynamic array. And of course, dynamic arrays are random access ranges. Whereas you go down the layer with bidirectional ranges, they lose the ability to be iterated in the middle. You can't index them in any way, shape, or form. More like, for instance, if you had a linked list and you got a range over the linked list, then you might have bidirectional range to be able to access the front and the back of the range, but you have no ability to access in the middle because it can't be done efficiently. Similarly, forward ranges lose the ability to be accessed at the back end. They can only be accessed at the front end. And then basic input ranges, like forward ranges, can only be accessed for the front, but the key difference is that there is a way to get an independent copy of a forward range to be able to then iterate separately. So effectively you can iterate through ranges multiple times with a forward range, whereas the basic input range has no capability to get an independent copy. So you can only iterate through it once and only once. So just in terms of the basic API as it stands, basic input range and all the others have empty front and pop front, where empty tells you that there are no more elements. Front gives the current element, assuming the range is not empty, and pop front pops that element off to go to the next element. So this gives you the basic iteration capabilities. Save then returns the exact same range type that you're already dealing with, but that range then is an independent copy of the range you're dealing with so that you can iterate through them independently, but they then have the same elements in the same order. And this is then useful for all the algorithms that need to iterate through ranges multiple times. Whereas with bidirectional ranges, they can get back and pop back, which are then just the back end version of the front ones. And random access ranges give you the ability to index arbitrarily in the range, and length comes with that because you need to know where the end of the thing is to index it properly. For any generic API, particularly Div templates, there are some things that you can check statically and some things you can't. Ideally, everything would be statically checked and you get a compiler error when you screwed it up, but such is not life. Like I had a coworker at one point who seemed to think for some reason, if you compiled Java, it was guaranteed to not have any bugs if you compiled it correctly. I had no clue why he thought that, but that's not the world we live in, unfortunately. So, some of the things can be statically checked with the range APIs. It checks that a range has front, pop, front, and empty. Checks their signatures to make sure, for instance, empty returns bool and not some random foo or something. With a bidirectional range, it makes sure that front and back return the same type, or with a random access range that op index returns the same type. You can't have different types from each of those because it's one element type for the range. Random access ranges with length has to be size t, could be a function, could be a variable, but is random access range can actually check that, giving an error if you don't provide length. On the other hand, there are things that are behavioral requirements that if you don't implement and implement correctly, algorithms are not going to behave properly with your range, but we can't actually statically check it. For instance, front has to return the same value every time that it's called until you call pop front. If it changes for whatever reason, there are various algorithms that are going to break. Some will work because they only call front once, but others call front multiple times. and you will get fun bugs if you implement a range that for some reason returns different values for front before pop front is called. Similarly, if you're dealing with independent copies of the range, so you call it save, the result is required to be a range with the same elements in the same order so that you can iterate through either one and get the same stuff. Can't be different. Another thing that I think sometimes is forgotten is that all the range API functions have to have an algorithmic complexity of O of 1. The various algorithms in Phobos have complexity guarantees. They're not always listed, but if you have any algorithm, you want to be able to rely on the algorithmic complexity, you have to be able to rely on the algorithmic complexity of each of the operations that it's using. And for ranges, those all have to be O of 1. So for instance, if you have a range that it can only be accessed in O of 1 and to get at the fifth element, because you have to pop through each of them, it's inappropriate to give it the random access range API because it's not going to be O of 1, it's going to be inefficient, and when you use it with various algorithms, why it might actually work, the performance is going to suck. But those are things that you can't actually check with template constraints, but they're still required. Most of the problems with the current range API can be grouped into one of three categories. Auto-decoding is an issue. The fact that we have save and need to use it has proven to be an issue. And there are a number of items, I think they often aren't even thought about, which are behaviors that are underspecified or actually cannot be specified because of the variety of types that we allow to be ranges as things stand. These sometimes cause problems because the generic code cannot rely on the behavior when it's implementation dependent. There are some things that are inevitably going to be implementation dependent, but anything we can actually nail down with the API requirements then makes it so the generic code can rely on those behaviors and what it's doing, and you can do more. Auto-decoding would honestly take too long to actually properly explain because Unicode is stupidly complicated. But essentially, what it's trying to do is ensure Unicode correctness by default so that you don't have to worry about all the complications of Unicode. Your code is just Unicode correct and it works. Functionally, what this means is that arrays of char and wchar are treated as ranges of dchar. Char is UTF-8, wchar is UTF-16, dchar is UTF-32. They're all different encodings of Unicode code points. And UTF-32, each element is guaranteed to be a full code point. That is not the case with char or wchar because UTF-8 and UTF-16 are variable length encodings. So it's very easy to write code in general, which is dealing with ASCII, which works perfectly fine. It's accessing stuff in the middle of your string, and then you get some actual Unicode characters, and you're chopping into the middle of code points and dealing with garbage. And so in an attempt to solve this problem, the range API on arrays of char wchar decodes the code point from the beginning of the range and returns that. And that's then what you get. So you end up with elements of dchar, even though that's not the actual element type of the array. This was a noble goal, but in reality it doesn't work, in part because code points aren't actually guaranteed to be characters, even though apparently the Unicode spec, as I recall, sometimes uses the term character for them, which is arguably stupid, but Unicode is complicated. Ultimately, auto-decoding has failed, primarily because it doesn't actually give you correctness by default. If you want full correct Unicode, you have to learn a bunch of extra junk and do that correctly in order to have your code work correctly with Unicode. Auto-decoding does not help you with that, really. In fact, it makes life worse because you don't necessarily want to be doing the decoding in a lot of cases, and it becomes an efficiency problem. So anyone who actually knows what they're doing doesn't want auto-decoding. And the people who don't want to bother with the problem and just have it automatically solved for them don't have it automatically solved for them because auto-decoding only deals with code points. And this has complicated Phobos considerably because of all the code that attempts to work around the problem to deal with efficiency issues. And it partially manages to do so, but it's just a complex mess. And we'd rather simplify things that will inevitably introduce more bugs in some people's code when they do things like do random access on an array of char. But we can't really prevent that ultimately in the current situation, just partially fixes some of those issues. But the only real benefit, I think, ultimately of auto-decoding is because it's kind of in your face. It results in a lot of people being forced to learn a bit more about Unicode and go and figure out how that actually works so they can do what they're going to do. But we don't want auto-decoding ultimately. It has caused too many problems. Save has also caused problems. It's required to get an independent copy of a forward range, largely because of classes. because if you have a dynamic array and you copy it, then you're guaranteed that you're getting an independent copy with regard to the iteration state. Dynamic arrays are pseudo-reference types, so you don't actually copy all the elements. You just end up with a slice of the same memory. But each array can be iterated independently. And so there's technically no need for a function like save. You can just pass them around, copy them. Each one's going to be independent. The same is true for a lot of structs. But for classes, they're reference types. And so if you just copy them around, you're going to end up with no independent copies whatsoever. They're just going to be fully dependent copies, and you're going to have bugs. However, because the vast majority of ranges do give you independent copies when you copy them, you end up with bugs in programs because people forget to call save. And even if you test your code thoroughly, this is easily missed because you have to make sure you test it with the correct types that would catch this particular problem. So ideally, we just wouldn't need save, and we could just have the same copying behavior you get with dynamic arrays, so the problem's just not a thing. And just generally speaking with copy semantics, with the way range API is currently done, we can't rely on them in any way, shape, or form, because you have 4 variations of copy semantics right now, depending on how the range is implemented. You have value semantics, in which case you're getting a full copy of all the elements, and so the copy is clearly independent. You got a reference type, at which point you're just dealing with a class or a pointer, and it's fully dependent when you make a copy. Or you got a pseudo-reference type where the iteration state essentially has value semantics, but the elements themselves aren't necessarily copied, and that's what you get with the dynamic array. So you end up with independent copies as far as the iteration state goes, but you're not actually copying all the elements. And then the nasty one is the pseudo-reference types where their iteration state doesn't get fully copied. And so you end up essentially with a partial copy where like some part of the struct is value type and some part is a reference type. This happens particularly with basic import ranges where they've stored front and yet they have a pointer to something else to give them their iteration state. So if you make a copy, you're getting a value copy of front, but a reference copy of the rest, and that just causes issues. So just some simple examples on that. If you copy a range and you pop off an element from the original range, the state of copy is unknown at this point because depending on the semantics, you could have ended up with an independent copy, or you could have ended up with a complete dependent copy, or you could even be in a state where it's now the copy is actually in an invalid state because you popped something off of the original one instead of the copy. And if you pop it off of the copy instead, you're in basically the same boat as just the original range, which is screwed up potentially. This means that in generic code, when you copy a range, you basically have to treat the copy as invalid and never touch it again, which can cause issues. And there are people that are going to forget that some of the time because, like with the dynamic array, it's a non-issue. But there are ranges where it's a serious issue. And to work around this problem, of course, forward ranges have save, so you can explicitly get an independent copy. But this doesn't entirely work around the problem, since there are plenty of other cases where you copy a range and you're not even thinking about it. One case is for each, and this particular problem came up in the news group recently, where someone wanted to iterate a range with for each, and then at some point during the iteration, they wanted to break out a loop and then continue iterating the range afterwards. While this will work with certain ranges, in generic code, this will not work. And if you look at the lowering, that helps explain why, and that the range is copied when you iterate with for each. And so you're iterating through the copy. And so again, we have the problem because the copy semantics aren't defined. The state of the range after for each is going to vary wildly depending on the implementation of the range. Of course, the reason it is copied is to emulate the dynamic array semantics, since I believe that gets lowered to a for with indices to access everything. But the result is that when you iterate an array with for each, you don't consume it, you just iterate through it. So you don't want to be consuming the range. It's on a dynamic array, so we do a copy. Now it's still going to consume it in the case of a basic input range because you have no choice. And of course you can call save to then get an independent copy. But just overall, you have to avoid doing anything with a copy with an original once you've made a copy. And this causes issues just because the semantics, again, are inconsistent. And the assignment semantics are basically exactly the same issue. It's just that instead of getting a new variable, you're replacing the state of current variable. And so what you assign from has to be considered invalid in generic code so that you don't have behavior that's only going to work with some range types. Another issue is that init value is poorly defined. The range API really doesn't say anything about it. And because it allows such a range of types, you have wildly different semantics for the init value. Extreme cases, the class is null with init value. So if you try and do anything with it, you get a segfault, your program's dead. This particular example is a reduced one from a bug report from the protobuffer guys because there was a change to Phobos' chain function which broke their code. Because they were making the assumption, which is technically a bug on their part, that the init value for chain was both valid and empty, which was previously true. And this is the kind of thing that a lot of times, if you're not really thinking about it, you're just going to make that assumption because that's the obvious thing. It's how dynamic arrays work as well. However, the implementation of chain was changed in order to try to make it more efficient. That resulted in it no longer being the case that it was valid and empty, so their code broke. Current range API just makes no guarantees about the state of init and cannot do so because of such extreme differences in the types that ranges can be. But another thing that pops up occasionally is, in the general case, there's nobody an empty range of the same type from a range without popping all the elements off, which is now O of 1. If it's sliceable, then you can slice it with 0.0 and you get the same type. But like for forward ranges or bidirectional ranges, you can't do that. So if you have a case where you need to retain the same type, like in this example, you've been passed in a reference to a range, and it makes sense for this code to make it empty. There's no way to say, hey, we want to make this empty now and return so that when you then look at it afterwards, it's empty. In this case, the code is using the init value, which for many ranges will work, but of course in the general case does not. And there's just no way to do this in the general case. The closest we have is take none, which wraps it to create another range that is then empty, which works for use cases where you don't need to retain the type, but it doesn't work in any case where you need to retain the type. And so this is a hole in implementation that'd be nice to fix. And the main reason it wasn't fixed years ago was because of the init problem. Another thing that pops up is what we call transient front. The prime example of a function that causes this issue is byline in standard I/O. In the vast majority of ranges, it is perfectly fine to copy front and store it and do other things with it. So you copy front, you call pop front, and your variable stays the same. However, it is technically possible to do things like return a dynamic array that's being used as a buffer, and pop front reuses it to get a new value, which is what byline does. And so that means your copy has now changed. The vast majority of code assumes that this is not a thing. So it routinely causes problems when it is a thing, which is why we added byline copy for the cases where you want to do something other than iterate with for each. But the fact that this is allowed causes problems. Another thing is non-copyable types, which is not strictly a problem with the range API, but it's not something that we generally handle very well, partially because non-copyable types kind of suck, honestly, but there are cases where you need them. The algorithms in general in Phobos don't even think about non-copyable types. They don't test for them. They don't try to work with them, whatnot, and we need to have a more consistent story of what we're doing with non-copyable types. Even more so with some of the changes we're going to be making. Another thing is with random access ranges, for some reason, random access range doesn't actually check for slicing. Slicing is a separate trait. As far as I can determine, if you can randomly access a range in O of 1, there is no reason why you can't slice it in O of 1. Similarly, if you can slice it in O of 1, I see no reason why you can't implement op index in O of 1, but has slicing will technically allow you to implement a forward range with slicing. So as far as I can tell, that just makes it so that you cannot bother to implement slicing on a random access range, even though you're probably going to run into cases where you used your range with code that assumes that slicing was the thing for random access ranges and had a bug. Or you just decided to have slicing for some reason in forward range and were too lazy to add op index. I don't know. But as far as I can tell, functionally speaking, there's no reason to be separating these two traits. Just put the slicing on the random access ranges, and that will be one fewer trait that we have to worry about because we have way too many of those already for all the variations to be worrying about. Another problem, there's another underspecified issue here, is random access range and has slicing don't check for op dollar because Andre forgot. The result of this is there is no guarantee that a random access range has implemented op dollar. The result of this is, in turn, that you cannot use op dollar in generic code because it will not work with ranges that didn't implement op dollar, and there's no guarantee that they did. So ideally, we would just have that requirement so that we could rely on op dollar. In most cases, it's just aliasing links to op dollar and you're done. That's not required right now, which effectively means indexing and slicing can't use op dollar, even though ideally we would be able to. And just in general, constant ranges don't really mix very well. Constant elements are generally just fine. But of course, pop front doesn't really make sense with const because mutating the range to do the iteration. While this isn't a huge deal with a lot of code, because when you're passing around all this templated stuff, there's no requirement to like slap const on things. It's not a big deal. You're not going to end up with the const range in most of that code. As soon as you start dealing with containers and putting ranges within other objects and whatnot, it's pretty easy to get in the situation where you have a const object containing a range that is then const, and the range is then effectively useless. Arrays do not have this problem because they have a bit of compiler magic, where if you slice them, you get a tail const copy, which means that instead of a fully const slice, you then have a mutable slice of const elements. In fact, templates with implicit function template instantiation specifically instantiate with the slice type, not the actual type of the array, which makes it possible to pass like an immutable array to a range-based function, and it just compiles without you having to dupe anything or cast or whatever, or slice it explicitly, because the compiler knows that it can make that conversion safely, and it's going to be sliced when you pass it to a function anyway, unless it's ref. We ideally would have that kind of capability with ranges in general, but we don't. And the last issue I have here is one that Walter in particular didn't like, in that currently you have to import standard range or standard range primitives in order to treat arrays as ranges. Ranges are not first class in the sense that arrays are treated that way, in spite of the fact that ranges are essentially an abstraction for dynamic arrays, and we use them all over the place. So at least it would be nice if we didn't have to import a module just to be able to use arrays as ranges. Not the end of the world that we can't, but it's annoying. As for changes, top of the list is actually one of the main reasons that Phobos v3 was started in the first place. We want to get rid of auto-decoding. So we're getting rid of auto-decoding. So all arrays of char and all arrays of wchar will be ranges of their actual element type. This means that you won't have the decoding going on automatically, you won't have UTF exceptions potentially being thrown from that, et cetera, et cetera. Now, we already have the functionality in standard UTF to do all this manually. We have decode, we have decode front, we have by UTF, by char, by wchar, et cetera, to allow you to decode UTF 8 and 16 to code points. And we have ranges to then wrap other ranges to give you other versions of UTF. It's just that with auto decoding, it's done for you automatically, so you have no choice on the matter other than working around the special cases to get around it. And because these various functions give you the choice of whether you want the replacement character or UTF exceptions when you run into invalid Unicode, you have the choice for how you handle it in your program. The other major change is the current plan with Phobos v3 is we're largely going to be dropping anything that isn't UTF-8. Right now, if you have a function that takes a string, in most cases, we then try to templatize it to have it take a range of dchar so it can handle all those variations. And with Phobos v3, it would then take a range of char, not wchar, not dchar, but we would have the wrapper so that if you, for whatever reason, have a range of wchar, you can convert it to a range of char and have it do its thing. But that will simplify the code that we won't have to deal with all those different encodings, which will help life. Next thing is, if the range can be default initialized, then it has to be valid. And if it's a finite range, and it then also must be empty. So that, like in the chain case, you can actually rely on that behavior. And if it can't be default initialized, you're going to get an error for trying to use the default initialized one anyway without giving it a value. In the case of infinite ranges, of course, they are going to be infinite, so they can't be empty, so they'll have to be non-empty. But this cleans up the situation with a net. It does get a little bit more complicated. I don't really want to take the time to go into it at the moment with disabling default initialization. And how to handle that. At the moment, the current plan is that we're going to have a free function called empty range, which will work with any finite range that can be default initialized, which is probably 99.9999% of them. And that one will then be guaranteed to give you an empty range from the init value that's required to be valid and empty. And in the very rare case where you disable default initialization for some reason in a finite range, you'll be required at that point to implement empty range yourself so that someone can use that to get the empty range. But much as we'd like to disable default initialization, there are issues with regards to infinite ranges and their state where you can't really force them to have a valid init state when it actually needs runtime information because they can't give you a valid state without that runtime initialization. So the init value is just not going to work. We would need default constructors or something to handle that in all likelihood. But we don't have those. To try and fix a number of these issues, particularly with regards to copy and assignment semantics, major change here is that ranges must be dynamic arrays or structs. a pointer and a class and the like cannot directly be a range. Now, we still want to be able to do all the stuff with classes that we do with standard range interfaces. We don't want to lose that functionality. But we do want to lose the problems with regards to all the inconsistent semantics. If you're dealing with a pointer, you're dealing with a class, they're going to be wrappers that will then handle that correctly and give them the correct semantics with the struct so that you can rely on the copy semantics. Don't have to worry about whether you're called save or not. Ultimately, this will then allow us to put requirements on ranges that give us consistent copy and assignment semantics without having a stray function that we all forget to call half the time. And on that note, there will be no save. Instead, copy semantics are required to give you an independent copy. Technically speaking, this is not necessarily identical to save, and that save right then gives you an independent copy. Whereas if you make a copy, if you have a class inside that struct, we don't want to be duplicating it all the time necessarily, because that would be wasteful if it turns out that the original isn't around anymore and there's really only one copy. So it would be possible internally to do something like reference counting and look at the state in pop front and say, oh, the reference count is only one. We're not going to bother actually duplicating the state because we know this is the only copy. It's unnecessary. Whereas the ref count were 2 or more, we know it's necessary. We're going to duplicate it. So it will be possible, depending on how the ranges are actually implemented, to avoid unnecessary copies. But in terms of usage, once you make a copy at a forward range, it must be an independent copy, and then all range-based code can rely on that behavior. The flip side of this kind of sucks, because what currently defines the difference between a forward range and a basic import range is save. With save gone, there's no longer a difference. However, if something that's a basic import range, it's because it cannot implement the save behavior. There's no way for it to efficiently give you an independent copy. That's why it's a basic import range. So essentially, the fundamental difference between basic import range and a forward range is its copyability.
I thought the forward ranges had to have a length and input ranges didn't.
Only random access ranges have to have a length. It is possible for other range types to have a length. They're allowed to. It can be checked for.
Range exists without a length.
Well, look at it like a linked list. You don't necessarily know the length of the list.
Okay, yeah. Fair.
There are plenty of cases where you'll have length when you can have length, and it's going to be on there. There's an option. It's not tied to a particular range type, except for the fact that random access ranges are required to have it, because if you don't have it, you're going to have problems with indexing. But because the fundamental difference between a basic import range and a forward range is the ability to copy its iteration state, the simplest way to then differentiate them and avoid all the bugs from partially copying state is to make it so they are non-copyable. The alternative would be giving it a separate API so that the code would not match up and you wouldn't accidentally use a basic import range as a forward range. Downside is you then have to duplicate all the functions that might work with both, which you don't really want to do. Plus, if you're really going to make them that different, maybe you should just make them a completely different thing and work on some other set of benefits with additional functions or semantics or something that don't necessarily fit in with the rest of the range API. So the decision was to make them non-copyable, which will be annoying in a number of cases, but for the most part, it's going to prevent bugs. This means that pretty much any function that's taking a basic input range is then either going to need to take by ref so that it can take the value because it's not copying it, at which point there is no copy whether they're doing the basic input range and a forward range, and just the semantics of that function are that it's mutating what you passed in, or you have to do an explicit move to pass it in to that function because it didn't take it by ref, at which point the semantics are essentially going to match what you had the forward range, and that you're passing it a range that function that gets ownership of, and you're not going to be doing anything with it in the function that you passed in. And since you called move, it now has the init value, so you're not going to have funky behavior going on if you screw up and accidentally use it. There are also improvements that are supposed to be coming to language with regards to move constructors and whatnot, including hopefully the ability to make it so that the last use of a variable would automatically become a move, which would reduce how much explicit moving we have to do. So some language improvements here would make this less bad, but most ranges or forward ranges are greater anyway. While this particular restriction of not being able to copy basic input ranges is annoying, it does fix a whole class of bugs, and it makes the difference between basic input ranges and forward ranges very clear. And as far as assignment semantics go, that pretty much just comes from what you would expect in the copy semantics. It's the same thing. You get an independent copy when you're dealing with forward ranges. And if you're dealing with basic input ranges, then it's going to have to be a move. If the compiler, turns that assignment into a move, then you're fine. Otherwise, you're going to have to do an explicit move to be able to move a basic input range because it can't be copied. For transient front, we're just going to say, no, you can't do that. There are other ways to get this behavior without altering the return value after calling pop front. For instance, if you really only care about for each, you can use off apply. There's no need to use the range API for that, much as it's nice. Alternatively, you could use an uncopyable type, and we are going to make that work better than we have. So if you use an uncopyable type, then they can't copy front, and you can just reuse your buffer as much as you like, knowing no one's screwing with it. Or maybe you could do reference counting. I'm sure there are other solutions that could be used that people come up to work around the problem, but I don't think that there's anything fundamental about transient front that requires that we support it in any way, shape, or form. There are other ways to solve this problem without making things worse for all the other range stuff, having to worry about it. So for non-copyable elements, it's not really changing the range API, but again, we're going to essentially make it so Phobos 3, any range-based function either has to use a template constraint to reject non-copyable types because it's just not going to work with them, or it has to work with them and is going to be tested with it appropriately. You can test fairly easily whether the element type is copyable already just with __ traits, but we do have a number of traits already for has movable elements to check whether the elements are movable and some things like that. So we may or may not add a specific trait for that, but either way, there's going to be a standard way to test whether the element type is copyable. That's going to be needed to use in Phobos to ensure that template constraints do their job with regards to that, and that we don't forget that this is a thing. As for tail cons ranges, we're punting insofar as this is really a wider problem. It's not just a range problem. And ideally, we would fix the issue in the language itself. Walter currently has a dip that attempts to do this. I haven't looked at it for a little while, so I don't know if it needs work, but it is attempting to make it so that you can then get a tail cons copy of a struct in D so that we can then hopefully emulate the behavior you get with dynamic arrays. I think the one thing it was missing, if I recall, was it didn't do anything with template instantiations, because if it really was going to match that behavior, then you instantiate a template with IFTI, it should use the tail cons version, which I don't think was in there. But either way, current plan is we're going to use dip with the language to fix this, which would also fix it for Phobos v2. We considered some other API changes to make it more like functional programming with head and tail and things, and it just didn't really clean up the problem. It introduced some other issues, and it would be a much larger change. So we're punting on this one and going to hope that we can get the dip sorted out with this to fix the issue in general. The major change, we need to do it for a couple of reasons, but we need to change the function names on ranges. The number one reason for this is that if we put these functions in object.d, which is the most straightforward way to then make it so that all arrays are ranges by default without importing anything. This causes conflicts with the functions in standard range primitives. And we can't move the functions from standard range primitives into object.d because the ones in standard range primitives have autodecoding. And we need the autodecoding, as terrible as it is, to continue to work in Phobos v2 so we don't break it. There's also a compiler bug or design bug. I forget the exact details off the top of my head, but basically using selective imports with range primitives and standard range primitives and standard range for the range functions, if the functions are in object.d, doesn't work. You can't actually fix the conflict. You still get an error. That may or may not be fixable at the language level, but it's just far cleaner if we put a different set of functions in there. There's nothing where you accidentally use one over the other, and so renaming the functions makes it so we can stick them in object.d and make it so you don't have to import something to get them, and it's much cleaner. The other issue is that the old basic input ranges, which don't have save, then look like the new forward ranges, which do have save. And the vast majority of these basic input ranges, of course, are copyable, even though you're not getting an independent copy. And so if we don't change something in the range API, you're going to have basic input ranges passing the template constraints on the new is forward range, and they're going to have incorrect behavior. So we really want to block that. We want that to be a compilation error. And so using new names fixes that issue. It's a different API, even though it's functionally the same in terms of what each of them do. That's a little bit annoying, but it also makes it so if you look at the code, you know whether you're dealing with Phobos v2 ranges as opposed to v3 ranges. You don't have to be confused about it. So it should improve usability from that standpoint as well. Now, this does require a dip because of for each, because for each knows about those functions in order to implement for each working with ranges. So I need to go and write that. Hopefully it won't be a big deal, particularly since Walter wanted this anyway. But there are, of course, some details about if someone is stupid and implements front and the new function on there, which one do you get? Just like if you implement the range API and off apply at the same time, for each has to decide which one it's actually going to use. The names that I'm planning to go for here is just front's going to become first, pop front's going to become pop first, empty will be is empty, back will become last, and pop back will become pop last. So they're just basic synonyms for what we're already using. Don't think it's particularly confusing. And it's clearly a different API, even though functionally it's the same thing. And so aside from like some behavioral requirements like not having save and whatnot, your range-based code in general is just going to be the same that it was, except with some different names. And there will be fewer bugs related to underspecified parts of the API and the Phobos functions, and other people writing their own functions can rely on the stricter semantics. And in the end, I don't think it's really going to add any restrictions to any user code in terms of what they're doing. It's just going to let you do more stuff because you can rely on more concrete semantics instead of having a lot more of it be unspecified like it currently is. In terms of implementation details, obviously all the traits and basic helper functions we currently have are going to be ported over in one form or another for the new range API. There may or may not be some name changes based on the whole Phobos v3 thing with general name changes depending on what we're doing, or they may be exactly the same depending on what we're talking about. Also, as far as the standard range interfaces go, we're going to be creating wrappers to deal with all that. So you're still going to have a replacement for standard range interfaces. If you need classes that are ranges, you're still going to get all that functionality. It's just they're going to be wrapped in structs, and because those wrappers are provided, you don't have to go implement stuff like the reference counting to deal with avoiding additional copies when you don't want to be copying all that data and don't need to. Similarly, the plan is to create wrappers for ranges to convert between the two APIs. And it's possible to be some caveats on that because the old range API doesn't have the same level of guarantees, and I haven't finished going through all that yet, so I don't know if there's going to be something where I'm going to have to say, okay, this might have this issue. But ideally here, we're just going to create wrappers so that you can have code that gives you your Phobos v2 range that you then pass to your Phobos v3 code, or vice versa, and be able to deal with that so that it just works nicer in general. So obviously, long-term, ideally, things would shift over to the new API. And another big thing is I very much want to supply a lot more test helpers than we currently have, because there are a number of things that we can't statically check. There are actually some things you can't really test with unit tests either, like verifying that the function's O1 doesn't really work with the unit test very well unless you're just dealing with huge data. But there are a variety of things with ranges that we can test with the unit test pretty easily. And if we can provide more helpers to test your function, range-based function with a variety of ranges, to test your ranges to make sure that they're behaving properly in a variety of circumstances, then it makes it a lot easier to write tests and make sure your code's working correctly without having to come with all that mess yourself. And you're less likely to run issues because you forgot about a requirement and didn't implement something correctly. The other big thing is the documentation needs to be improved. I think in general, if you look at like standard algorithm, the documentation of the functions is generally pretty good with some nice examples, but we don't really have any overarching documentation that's particularly good that explains exactly what the deal with range is and how range-based code typically works. And so if you're coming from another language, most of which don't have anything like ranges, you're going to be pretty confused in a lot of cases, and we need to do better about providing an explanation for that so that people then know how to use them. Similarly, we need very clear documentation on the behavioral requirements. We do have some of that documentation right now for the current range API, but there are a number of behaviors that are emergent from what we've done that are not immediately obvious that you might screw up because you don't know about, even though it's a general requirement. We want all those requirements, ideally, to be listed out in a way that if you're implementing a range, you know what the requirements are, and you don't do something like have a copy not be independent for a forward range. You know exactly what the deal with that is. So just clear documentation on how that works, plus the assumptions you can make based on those would ideally be clearly documented as well, so it's easier to write range-based code using ranges and not be doing things that actually you can't do, but you didn't realize that because you didn't know enough about the details. So just overall with the documentation here, I think we need a much better story of explaining the general concepts and exactly how that works so that it's easier both for new users and for people who are looking to implement a lot of this stuff in their own code, which that gets me to questions.
I'm thinking if you want to port an old range to a new one, can you just use alias?
In terms of taking a range from the old API to the current API, in many cases, it's going to be as simple as just changing the names. And yes. So, but like if you're then writing a range in your own code, or you're writing code that's using a range, it's going to be fairly straightforward in most cases to just change it to use the new names and it will work. Just there are certain requirements that you have to be careful of, like if you're doing the forward range, it's no longer saved, you're going to make sure the copy semantics are correct, whatnot. But for most code, these extra requirements are what it was doing anyway. You just couldn't rely on it because we didn't define it, and there is code that doesn't follow it. So by adding those requirements, we can then rely on it. And for the most part, your range-based code really isn't going to change much other than you're not having to explicitly call save. Basic import ranges will be a bit more annoying because of the non-copyable aspect, but most ranges or forward ranges are greater anyway, and you're going to have to change the names in your code. A bit annoying, I'm sure, in some cases, but it's very straightforward because we're looking to have this be essentially the same thing with some fixes, not completely change what it's doing.
The tail const thing, how is that a generic problem? Because I can definitely write a range that could take some const elements from another range and then be tail const. I don't understand what's the general problem there.
Well, for starters, if you're slicing a range, the requirement is that it has to be the same type. Causes issues otherwise at present. We could potentially say it could be a tail const type instead. But if you're wrapping enough stuff, you don't have the way to get it. With dynamic arrays, the compiler is able to look at the type and know exactly what's going on and avoid any funny business. That's not necessarily possible with other types because it's more complex.
Automatic, but you could write code to do that, right?
In at least some cases.
I mean, if I have a const map result, I could get the first element, copy that, everything, and have a non-const map result of const.
Yeah, but I mean, if a separate set of functions we have to call essentially to get that, and it complicates things where it's automatic with dynamic arrays. I mean, worst case, we could look later at adding something to do that, but there's already a dip that's trying to fix the problem, and whether the exact dip is what makes it in or not, we should be able to fix the problem with a dip, and then that just solves the issue, and we don't have to further complicate the range API to solve the issue, particularly since it's not something that happens super frequently anyway, and there's already a lot going on with the range API, so if we can avoid adding extra complication, it's better to avoid adding extra complication.
So if I understand correctly, it's basically, let's do some work in the language/compiler so users don't have to write code to make this happen for their own ranges.
Yeah, well, with the dip, as far as that goes, if it solves the problem for you, then you don't have to do extra work. So we'll have to see exactly how that comes out, but that would ideally be what we do. The main thing that we're not doing is head and tail kind of functional solution, because that would be too big a change, and it didn't really seem to solve the problem anyway when I looked at the details, because you've got different types changing depending on the constants and all that, and it got ugly.
A question about what it means to be independent for ranges. Like slices are copyable, but if you copy a slice, they will refer to the same elements, and you will see this aliasing.
The iteration state is independent.
Okay.
So we're basically trying to copy what happens to dynamic arrays, except there are, of course, value types where they actually copied all the elements, and just there's enough complication with various types that it's rather difficult to go, oh, this has to be a reference to something so that you can mutate it for the same from either. We don't want to say it has to be a copy because that's going to be a decopy of things. That's not how it works with dynamic arrays. The range API, for the most part, is not really concerning itself with what happens if you assign an element. There are some algorithms that do that, but that is going to be implementation-dependent behavior insofar. I mean, you have has mobile elements you can test to see about moving out the elements, but whether that's then going to affect another copy is then going to depend on the implementation. So you pretty much have to assume at that point that the other ones are invalid if you did something like move elements. But as a general rule, they're independent in that the iteration state is independent, and what happens to the actual elements themselves in terms of whether they were copied is implementation dependent. Much as it would be nice to be able to just go, oh, they're like dynamic arrays for everything, there are too many ranges where it's really not going to work to give them that semantics. I'd like to nail it down more than it is, but for the vast majority of range-based code, you're just reading what's there anyway. You're not mutating, so it doesn't matter.
Yeah, I mean, I guess there is the issue of nested ranges. For example, in Phobos, there's a transpose function that will consume all the inner ranges. So I guess Phobos v3 is going to keep that weirdness where functions sometimes mutate, even though it seems they shouldn't.
Yeah, I mean, I'd have to look at the specific thing to see what we could do with that. That does get uglier. Some of that's going to get uglier just with basic input ranges being non-copyable. But you're going to also naturally going to end up with copies in more cases because of how forward ranges will then work. So there may be some specific cases where we have to look at it and decide how we want to go about it. But in terms of defining what exactly is happening with the elements as to whether they're copied or not, I don't think it is functionally going to work to put a requirement on that because there's too much variation in what we do with ranges to make that work, much as it would be nice to nail that down as well. So this doesn't nail everything down, but it does nail more down.
Yeah, I mean, on that note, another thing that is confusing to me is how you would implement first for a slice type whose elements are non-copyable.
Well, it would return it by ref, which you can already do.
So the user has to put something else in slice while iterating.
I mean, dealing with first becomes more complicated in general. When you get the non-copyability, there may be a variety of cases where we're just like, sorry, this isn't going to, non-copyable is still not going to work with this code. The core thing here is to ensure that we're dealing with non-copyable consistently and improve that story. So there may be some details that we need to tweak to make things work or nail some more things down that I missed. That's certainly possible. I mean, this is based on the issues I'm aware of and what people pointed out in terms of what we're doing with it. It's quite possible there are additional issues that we're going to find going through the process and have to nail something down further.
To the extent that the range rewrite doesn't depend on object D changes, are you considering putting the parts that are independent of that up on dub somewhere so people can test their software with it?
Well, at this point, it would go into the Phobos v3 part. I've partially implemented it. I haven't completed it. There's some other stuff for Phobos v3 with regards to the traits I need to finish, import things over. So it's not there yet, but there's a partial implementation. And when it's large enough, it will go into the Phobos repo in the portion that's for Phobos v3. And anyone who wants to mess with it can mess with it at that point.
Also, I'm not 100% sure if this is covered under the changes about tail const, but are you testing with values in ranges that are immutable? So immutable in the sense of immutable struct where you can't uncall it.
Immutable and const are basically the same problem at that point. So there shouldn't be a need to test explicitly for anything that's immutable versus const. And most of that stuff with regard to like highest assignable elements, it'll check, whether it's assignable, and it doesn't really matter why it's not assignable. I mean, it could be that you disabled off assign or funky things like that. A number of the things you don't have to get too specific on it to just test the behavior and you're fine.
About the O1 operations that you mentioned, in filter, for example, pop front has to be ON, right? Kind of have to skip all the elements, right? So that was mostly like a nitpick, but now for my more serious one, we were sold ranges and the composability of them. We were sold it as this is a really nice, rich, composable API. Mm-hmm. But it compiles down to extremely efficient code as if you wrote it directly yourself. And over time, we discovered that's not really the case. When you compose op-apply ranges, like ranges that use op-apply, it's actually correct. But when you use front, pop front, and empty and compose things that build on that, you do see a performance hit, and a significant one. And when we investigated why that is, we discovered that it's because if a range implements 3 methods, front, pop, front, and empty, each of those 3 methods is going to call the underlying range, which it composes above, also multiple times. Like front might call both empty and pop front, and not just one method. And the compiler refuses to inline, and for a good reason, because if you try to inline multiple calls to the same underlying range method, you're going to get an explosion of code size. And this refusal to inline means that they don't really get optimized very well. And in practice, we've seen that really. So my question is, if we're doing like a new kind of range thing, maybe we should consider changing the API to one that is prone to optimization, one that uses maybe a single method when possible to iterate, just like op-apply, so that inlining works and then we get the true performance that we were sold.
I'd have to think about that more, look at the details. Certainly part of the goal here is to restrict how much we're changing. If there are enough significant issues that we've missed, then we will look at adjusting what we're doing. Certainly if you have solid information on that kind of thing and post in the news group so we can discuss it and look at the details, we can look at what we would do to change it. Ideally, we'd be able to just do basically what we're doing right now. But if there are some significant performance issues and there's something very clear that we can do that was different, we may look at doing so.
When looking at the C++, the corresponding range API for C++20, I'm counting to 12 ranges in their hierarchy of the concepts. So I'm just thinking it might be worth considering extending the range hierarchy if there's some recurring patterns on how the template restrictions are going to be modified.
Well, I mean, if you have some concrete things there that you think would improve things, you want to post in the news group, we can discuss it. For the most part, it seems like we arguably have way too many traits already dealing with ranges and all the static shift branches and everything you have to deal with various types that it can become very complicated. If some extra complication would bring us some real benefit, it may be worth adding, but I don't want to be making significant changes like that without a clear benefit.
Regarding the complexity, I think somebody else kind of mentioned it, but I don't think you can require O1 for everything because you don't know what the underlying algorithm, like map, you can't require that pop front is going to be.
Well, it's O of 1 in the length of the range. So technically in the case of filter, it's arguably O of 1 because of the length of filter's range. Yeah. It's not O of 1 with regards to the underlying range.
And in the case of filter, the only one that's going to incur an O of n is the first time you call front. I think the main thing is like op index needs to be fast.
If there are enough examples, we may adjust that. But the main thing is that those need to be defined reasonably well so that you can rely on it. And if there's some exception in there where you go, well, this range technically doesn't do that. Performance characteristics don't like change code behavior in the sense of like it's going to do the wrong thing. It's just going to be slower. So there's nothing stopping you from doing something dumb, like saying, hey, this is random access range, even though we have to iterate through the whole thing to get at things. So we can, have exceptions to some of that if need be. And we may word the requirements slightly differently, but in general, we're not supposed to be like iterating through the whole range to do all these various operations.
I think it's good to document the expectation of like, this is how many times someone might call your front function. This is how many times someone might, so plan for that,
If I have a range where I have front, for instance, which is pure, can't it just be inlined? Why can't it be inlined if it's a pure function?
I don't know what all the inliner is going to do on all that. I'm not an expert on what exactly inlines, and it doesn't. So I can't really say. I mean, for the most part, pure doesn't actually change much in terms of what the compiler does. And I don't think it actually gets used at all by the optimizer, at least for like LDC and what have you. But I'm not 100% sure. Certainly, if there are issues with what's being inlined, we should be looking at those and seeing whether it's worth making changes to make that work or whether it changes too much. But like this is the first anyone's brought up that particular issue in terms of it being impossible to inline that stuff, even though it arguably should be.
Did you try to also specify the difference between computing a value and just returning a value or returning a copy? For example, with front, if we call front 2 times, does it mean that we compute something possibly with effects 2 times? Or should it have some guarantees about that each element is only computed once? Are there any attempts to clarify it?
It is required that it returns the same value every time. As far as computing it goes, as things stand, that's been completely left up to the implementation as to what they do it. I don't know if it makes sense to require it to be in one or the other. Part of the problem is, like, say, in most cases, for instance, you would do the work in pop front. It wouldn't make sense to do it in front. You're just going to do the work in pop front and store the thing, and then you return it from front. But in the other cases, like, say, map, it can't do that because it potentially works in random access ranges. And so you got stuff in the middle. It's not going to be caching any of that because that would be nuts. We may lock that down a little bit more if we can find some clear requirements on that to make it clearer. I think certainly we need to specify some of that a little bit more cleanly. Like, technically right now, you could do work in empty to determine what was going on with that, and that at minimum should be discouraged. We may lock that down somewhat further, but I haven't done so at present.
So my question right now is that given that range is something standardized by D right now, and we have an implementation of the UDA must use, I was thinking about we having UDAs for enforcing range APIs, especially because whenever you want to enforce some kind of ranges, you must import standard range interfaces. Also, you have to write plenty of ugly checkings inside your code. I was thinking about if we had this user-defined attribute, we could have better messages, better checking at compilation time, and even less code emission for being stripped by the dead code.
I'd have to see examples to see exactly how that would improve things. And as a general rule, I don't think it's going to be very pleasant if you have to put a bunch of UDAs and stuff. If it makes sense to have it as an optional thing to give some extra information in some cases, that may make a lot of sense. But as it is, we have to mark up stuff with way too many attributes in too many cases. So if basic range stuff requires a bunch of attributes, even if they're UDAs to do it, that's going to be really annoying. So I'd have to see some concrete examples of what exactly we'd be getting out of that to see changes. Certainly an optional thing is a lot more palatable than something that would be required.
I'm almost sure we had like compilation time tolling when I think Steven made a blog post on that about checking about range properties when you had like a plenty, and I saw that it had more memory usage for the compiler, and also the compilation time went like a little above than one would expect.
Well, ranges in general, we have an issue with compilation time in the sense that there are a lot of traits. There are templates that get instantiated with this whole mess. So just as a general rule, if you can reduce how much we're doing with that, that would be nice. Just so we can help improve it. We can't remove all of it, but like as Adam was talking about yesterday, reducing template usage, at least in terms of the depth of things, would help considerably because we're just instantiating too many stray things. And if we can reduce that where we don't need to, that's going to improve compilation times, as well as reduce the number of stray symbols that there are.
So I'd like to quickly go back to Steven's question about the running times. I think having some sort of universal requirement that front should be constant time is just a non-starter because of ranges like map, where the front will evaluate a user-defined function, and that may in turn use range algorithms inside, right? And so I think requiring a front of map to be O of 1 universally is on the same level as requiring that every loop body is O of 1. And I think nested loops are useful.
Well, it's O of 1 with regards to the length of that range. So if you're doing a whole bunch of stuff internally, it's not necessarily O of 1 in regards to the internal ranges that it's operating on. We can certainly adjust how we list that requirement. It's not a hard requirement anyway, in the sense that your code's not going to behave incorrectly, even if the algorithmic complexity is garbage. But if you want to be able to rely on the algorithmic complexity with regards to algorithms, we have to actually specify what the required algorithmic complexity is. And if you do something that doesn't match that, then okay, fine. Just you're not going to get the algorithmic complexity that the algorithm is saying it does.
Yeah, I mean, I just think you should specify it on a per range basis. Each range should say how fast it is.
Yeah.
Particular for map, you just say it calls the user supplied function once per each call to front, right?
Okay. Yeah.
About the UDA thing you were talking about, it would be just one UDA per type, basically stating this is an input range, forward range, whatever. And I have a prototype, I guess, of that in the concepts library. So maybe we should think about that. This is something that exists already. The only problem is you have to do it by convention. So the code that would usually go into is input range goes into a separate function, and then is input range, a template constraint calls that a compile time. And then this thing is then used for error messages. Basically what you try to do is try to verify that it's an input range, and if it isn't, it throws an exception or static assertion.
Okay, I mean, we can look at it and discuss it as far as that goes.
I think we're focusing too much on things like O1. I mean, at some point, think of how your range is going to be used and be reasonable in your implementation. If you're using a range that, has to start from the beginning and iterate to its correct position and then return, you're going to get horrible performance, and that's on you, the designer of the range. I don't think it's the specification's fault if you make a pathological implementation of a range. There's just, some common sense with this. Just try to make your ranges as efficient as possible, and you'll be fine.
Anything else? No?
No.
Cool. Then I believe that's all that needs to be said on the subject ever, and you should not discuss this on the forums, correct? Perfect. Thank you.
Yeah, because that's how things work.